So we did till over here, isn't it? I think I'm sharing my screen now. Okay, let me share the screen. Yeah, I think now I'm sharing the screen. Can you see it? Yeah. Okay, so right now we are going to start, and we completed till over here. Like we got to know how to place the third charge, or where to place that third charge so that the system must remain in equilibrium, isn't it? Yeah. Now, we left that second question of it, that can you just find that what amount of charge this capital Q should be? Yeah. What amount of this charge? You see, I'm still not aware. Okay, so it's your task. Can you just solve it? Can you tell me what should be the value of capital Q such that the system must remain in equilibrium? Okay, it's easy peasy. Okay, so look over here. How to do this question means how to find that what should be the value of the third capital Q charge such that it's it is going to be in equilibrium. So I'll not do this in a simple way. Let us just have a good discussion regarding this. Okay, so we got to know that if I can place some any charge over here, then it will be in equilibrium. But there is a much more insight of it. Okay, and we are going to talk about that only. So let's suppose I took some random charges. Okay, and I just place them over here. There are two different random charges. Okay, and the gap between them is distance r. Got it or not? Now, see, basically these charges are what? I call it as one as a small q plus q, another one as also plus small q. Got it or not? Now the point is very simple. I wanted you to put some third charge such that the system must remain in equilibrium, isn't it? Now the question arises that, sir, I can place that third charge in between the charges also. I can place it over here also. I can place it over here also. But which one is going to be true? Which condition is going to be actually satisfying that this charge Q, capital Q, must remain in equilibrium, whether it is first position, whether it is second position, or whether it is third position. So to talk about that in a much more greater sense, whenever you have this kind of a confusion, do not rely on doing the calculation mathematically. Rely on doing the calculation analytically. Okay. By understanding that in which direction the forces are actually present. Are you able to get me or not? So look over here. Let's suppose if I just consider my capital Q over here, somewhere over here. Okay, I place my capital Q over here. Now, this capital Q is also positive in nature. What is the nature of it? Positive. So what you are going to see? This, yeah. So this plus Q will apply some repulsive force over here in this direction, isn't it? This plus Q will also apply some repulsive force in the same direction, isn't it? Similarly, if I just place capital Q over here, okay, that same charge capital Q over here, which is positive, what you're going to see that the repulsive force is in this direction and the repulsive force is in also this direction. So what do you observe? That this capital Q has a resultant force along left side over here or not, and this capital Q is having resultant force along right side. So is there going to be in equilibrium? The answer is no, they will not be in equilibrium, isn't it? So how to keep them in equilibrium? Now if you see the third charge, if I place this charge over here, what you're going to observe that this plus q is trying to repel this q towards right side, while this plus q is trying to repel this charge towards the left side. So these forces can definitely balance by applying some condition. We can try that these forces must get balanced, and then then the system can regain its equilibrium or not. So what do you observe? That when it is placed over here, there is no equilibrium. No equilibrium can be attained. Here also, I can't get any equilibrium. No equilibrium can be attained. But here, there is a possibility that equilibrium can be attained because these forces can be definitely balanced. Are you able to get me or not? Is that clear or not? Yeah, and that is why we calculated this distance. We considered that this is located at distance x. Okay, this is located at how much distance? X from first charge. Yeah, so then this length used to be r minus x because this distance was r. No problem. You can consider anywhere. You can consider anywhere. You will get the same answer. Hold on. Is that clear? So now the question was very simple. That what is this capital Q going to be if this was Q1 and if this was Q2, isn't it? So tell me how to find that. How to find capital Q? The relation of capital Q. Mm-hmm. Can you tell me? Uh-huh. So whatever happens, if the whole system remains in equilibrium, then the net force on any of the charges must be zero or not. You calculated the net force on this and that gave you position. So definitely this equation will not give you the answer of capital Q. So what you are going to do? You are going to consider the net force on any of these two charges, F net to be equal to how much? Zero to remain in what? Equilibrium. Are you able to get me or not? So let's suppose if I consider Q1, then Q1 is experiencing two forces. One from Q2, another from capital Q, isn't it? Are you able to get me? So this actually also gives you the idea that what can be the sign of capital Q which is placed over here. Now you can see that if if I just draw these directions of forces on both these charges, these directions are actually repulsive in nature, isn't it? So that means Q1 and Q2 will be also thrown from the system. So that means that one thing is quite clear that this capital Q needs to be what? Negative in nature. कैसा होना चाहिए? Negative, such that they must be attracted. So Q must be negative over here. Q with Q1, it should be negative such that the force applied by Q2 on Q1 which is repelling must be balanced by this attractive force of Q1 is Q1. Right or not? So this line represents force on Q1 by Q2 and this line represents force on Q1 by capital Q. Are you able to get me or not? So if these two forces are equal, force on Q1 by Q2 is equal to force on Q1 by Q, then my system remains in equilibrium. So force on Q1 by Q2 is what? K Q1 Q2 divided by R square, that is exactly equal to F Q1 K Q1 into capital Q divided by X square, and you know the relation of X was R square Q1 into a square root of, okay. So basically people does not give Q1 and Q2, but I am writing the general equation. So root over Q1 plus root over Q2. 1 minute. I've taken capital Q1 and capital Q2. So root over Q1 plus root over q2 का whole square. Are you able to get me or not? So this makes our q1 and q1 got cancelled over here. K and K got cancelled. So therefore I got the relation of capital Q. It is the charge required is exactly equal to Q1 Q2, and R square also got cancelled. So it is Q1 Q2 divided by root over Q1 plus root over Q2 ka whole square. This is your relation for capital Q, which is required. Yeah, it should be negatively charged. Right on. Should be balanced. Got it? Then you will have the different relation. You will have to think analytically, draw the sign, draw these lines, and then you'll get the answer. So क्यू का पोजीशन तो हमने निकाल लिया ना, एक्स डिस्टेंस अभी पहले वही तो निकाला. तो चार अगर इंटरचेंज मतलब मान लो अगर हमने यहाँ पे Q2 ला दिया यहाँ पे Q1 तो क्या हो जाएगा, सिंपल R माइनस एक्स इधर आ जाएगा, एक्स इधर हो जाएगा, है कि नहीं? अगर तुमने हाँ, so that is your homework. So let's suppose if I have different charges right now you asked. So let's suppose if this is 1 minute minus of q1 and this is I'll just give the same charges. So this is minus of q, this is plus of q, then find, and the distance, initial distance between them is r. Okay, then find the sign comma magnitude and value of third charge which should be placed such that system remains in equilibrium. Such that system remains in equilibrium. Do it. That's your homework. Okay. It's a homework for everyone. Hold on. Is that clear? Okay. Can we move ahead? Now, look over here. Now, as we were discussing about this particular property of understanding that what can be the magnitude, what cannot be the magnitude, and all these kind of relations and all these kind of functions, there comes one more important case over here. Right or not? Okay. So you have to always keep in your mind that whenever I'm placing any charge, I should keep it in such a sense that the net force should be zero for the equilibrium. Is that clear or not? Okay. ठीक है. So now look over here. Now this was, so we did horizontal equilibrium, we did vertical equilibrium, we did all these friction cases. Now I'm going to include the maximum and minimum forces, right or not, and then I'll talk about one of the special case of stable and unstable equilibriums and all, right or not. Okay. So बोल रहा है कि yeah, so बोल रहा है कि a charge Q is going to be divided on two objects. Okay, a charge Q is going to be divided on two objects, then find the value of the charge on the objects such that the force between them such that the force between them is maximum, such that the force between them is maximum. Do it. बताओ जल्दी से. हम्म. इसके बाद अपन डिस्कस करेंगे अनस्टेबल एंड स्टेबल इक्विलिब्रियम ऑफ डिफरेंट डिफरेंट केसेस. ओके. A charge q is going to be divided on two objects. Then find the value of charge on the object such that the force between them is maximum. Okay. Let us understand. I have used the word term maximum over here, isn't it? Now, see, whenever, let's suppose I'm telling you one thing. Let's suppose I have given you this trick earlier also. If it is asking some functions to be maximum, let's suppose I want my y to be maximum, which is dependent upon some variable x, right or not? Then the first task is find dy by dx and then put it equal to 0. This is the way I'm going to, because after this step we can do this step of d2y by dx square, and we can find if it is less than 0 then the function is maximum or minimum or such that. Is that clear or not? Okay. So the process is going to involve these steps, that first put dy by dx equal to how much? 0. So here it is saying that I have two different objects. Means what I'm doing is that I just divided this total charge q on these two objects which are kept at some distance r. Got it? Okay. Now to try to see that, let's suppose if the charge on this is x, so on the charge on this will be what? Q minus x, isn't it? Then the Coulomb force between them will be represented as what? Simple. K 1 by 4 pi epsilon naught x into q minus x divided by r square. This is going to be my force formula, isn't it? Now look over here. This force depends upon this variation x or not. By how much amount I'm dividing the charges on each object, isn't it? But I want this force to be what? Maximum. Once again, it is like this. I want my y to be maximum and it is dependent upon variable x. So what I need to do? I need to divide df by dx first of all, isn't it? So what is going to be constant? 4 pi epsilon naught r square is going to be constant. And this will be d by dx of x into q minus. Is that clear or not? So when I do that differentiation, and then I need to put it equal to how much? 0. So what I'll get? Simple d by dx of x into q, which is x into q minus x square equal to how much? 0. And this gives us q minus 2x is equal to how much? 0. And that means x is equal to q by 2, which makes, if x is equal to q by 2, then my force is going to be what? it is going to be my maximum value. Right on. So that means what? On both of the spheres, the charges should be q by 2 and q by 2. Wherever I place it, the forces is always going to be maximum. Are you able to get me or not? If is still 0, then you see, I have directly written over here maximum and minimum. But actually, the process involves this thing. I have to then find, actually here already it is specified in the question that it is going to be maximum. So that is also true. You'll write same value. But to verify, you need to repeat these steps. Then you need to find d2f by dx square. Right or not? And whatever the value of x you got over here, you just replace in this d2f by dx square. Okay. And then check it. If it is less than 0, then my force at that value of x and this value of x is going to be my maximum value. Are you able to get me or not? If d2f by dx square for the value of x which you calculated is greater than 0, then f of x for that value is my minimum value. And if d2f by dx square for that value of x is equal to 0, then function is neither maximum neither minimum. It is a neutral value. Is that clear or not? Are you able to understand me? So if it is, see here it is a quadratic equation, so directly I am getting x is equal to q by 2. And if I find d2f by dx square, look over here. If I just calculate d2f by dx square, what I am going to be? df by dx is simply q minus 2x, isn't it? I'm just ignoring this constant. I'm just ignoring this particular constant. Okay. So df by dx is q minus 2x. So what I will get? I'll get minus 2 into some constant, isn't it? So what is this? This is already a negative value, and you know that for any value of x, if the value is negative, then force is what? Maximum or not? So that means the force is maximum for the value of x is equal to how much? Q by 2. Is this clear or not? Got it? Now, we discussed about this horizontal equilibrium, vertical equilibrium, many cases of equilibrium we discussed. The point is, equilibrium is not such a simple thing. Equilibrium, as in work for energy, we got to know that equilibrium consists of three different properties. That an equilibrium is, yeah, even categorized in three different ways. One is stable, another one is unstable, and third one is neutral, isn't it? The much more clear idea to understand this is simply, if it is a stable equilibrium, then it will be like, if I have a hollow sphere, if I place an object over here, then if I just displace it a little bit, it will once again regain back to its original case, original initial point, and then we call it as a stable equilibrium. Unstable was, if I just displace it a little bit, okay, then this particle will never ever return to its initial condition. Neutral is simply, if I place it on a neutral level, then it was going to be called as a neutral equilibrium. Are you able to get me or not? So these were our conclusions regarding equilibrium. But same thing can be told about the equilibrium of the charges which we are placing on here and there. And that's why I give this topic name stable and unstable equilibrium. Stable and unstable equilibrium of charges. ठीक है? Is this clear till now? Okay, so how to understand this? So what do we do? We are going to take some charges. Okay, and then, so let's suppose in the first case, Okay, I'll discuss over here. I had these two charges. Okay, and I just kept them over here. Okay, now the point is I can place any charge anywhere, isn't it? So these are my charges. Let's suppose this is plus q1. Okay, this is plus q1 and this is plus q2. Word or not? Okay, now what we do, I just took this charge and wherever there was an equilibrium point, I just placed it over here. Word or not? Okay, so look over here. Oh, shit. No. Yeah, I just placed this charge over here. Word or not? Now look over here on this charge. You can clearly see. Okay, let's suppose I call this charge as I call this charge to be positive charge. Okay, so I'm taking this charge as plus q, plus a small q. Right or not? So there are two different cases which we are going to discuss today. Okay, so this is plus q, which is placed over here. Okay, so case one, give the heading case one. If q1 and q2 are fixed and plus q is movable and q is movable and positive. सो फर्स्ट केस है कि तीनों चार्जेस कैसे हैं बेटा, पॉजिटिव चार्जेस हैं. कैसे हैं? पॉजिटिव. तो ध्यान से देखो जरा. दिस प्लस q1, लेट सपोज if I just displace this charge, this is small charge, by some distance towards right. Okay, by some distance towards right, what will happen? This charge plus q will experience some extra repulsion from this plus q2 or not, and from plus q1 this repulsion would have been decreased, isn't it? Yes, so this is the force on q by q1. This is the force on q by q2. So you will see that this force of q2 has been suddenly raised up, isn't it? So that means what will happen? If I just bring this, if I just move this particle towards right, this particle is thrown back to its initial condition once again, isn't it? Similarly, if I just displace it towards left, it will be once again thrown back to its initial condition or not. So whenever it is getting, whenever the charge is coming back, or whenever the particle returns to its initial position, which kind of equilibrium we call it? We call it as a stable equilibrium. Are you able to get me or not? So we can say directly the first point, the line joining, the line joining Q1 and Q2 is under a stable equilibrium. Is under which equilibrium? Stable. Is that clear or not? Now, what I did, instead of taking this horizontal line, I took this vertical line. Okay. I took this vertical line and I placed my charge over here. Word or not? Let's suppose this is also plus q, positive charge only. Okay. Now what will happen? If it is positive charge, this plus q will apply the force in this direction, or this plus q2 will also apply the force in this direction. Or isn't it? Correct? Are you able to get me? So now you think of one case. Let's suppose, let's suppose if I just displace this charge little bit vertically upwards or downwards, what is going to happen? Repulsion is going to happen. If I just displace this charge particle downwards, it will feel an extra repulsive force which will throw the particle away from its this initial condition or not, isn't it? Is this particle is going to be returning back to its initial condition, this position? No, because it will be thrown with an extra velocity along the upward direction, isn't it? So here what happens, that it will not return to its initial position. That is why the line perpendicular to line joining, yeah, हाँ ये चीज यहाँ पे नहीं हो रहा था क्योंकि दोनों तरफ से रिपल्सन है ना. हाँ, so line joining, line perpendicular to the line joining Q1 and Q2 is a line of unstable Q2. Is this clear? Are you able to get me? Let us repeat all these points with Q1 and Q2 to be fixed. Same, okay. But let us just take the second case of it. Okay, with Q1 and Q2 to be fixed, but this time there is a slight change. This is plus Q1, this is plus Q2, isn't it? But the charge which I placed over here in between them is a negative charge. Is a which charge? It is minus Q basically. So case 2, case study 2, Q1 and Q2 are fixed. Why? Q is negative and movable. Okay. Now what will happen? Let's suppose if I do the very small displacement in it. What is going to happen? When the charge appears over here, when the charge comes over here, so let me just draw. When the charge is over here, what it is going to happen? The force on it by Q2 will be what? More, and this will be the force. This will be the force on that by Q1, isn't it? So this one is the force on Q by Q1. This one is the force on Q by Q2. And this force is more attractive force in nature, isn't it? So what will happen? This minus Q will try to stay over here or not. It will not go back to its original condition, isn't it? So if it is not able to return back to its original condition, then yeah, of course it is going to be it is going to be attracting because of the opposite charges nature. अरे भाई Q1 भी प्लस चार्ज है, तो एक बात बताओ, यहाँ पे ये चार्ज है तो इधर का अट्रैक्टिव फोर्स कम होगा, इधर का अट्रैक्टिव फोर्स ज्यादा होगा ना। तो इसकी वजह से क्या होगा, वो चार्ज दिस माइनस क्यू विल नॉट रिटर्न बैक टू इट्स इनिशियल स्टेट ना। सो इफ इट इज what if you move it, then it is going to move towards Q1. If you do not move it, then it will not move towards Q1. Yeah, because it is attractive force, not a repulsive force like the previous one. Yeah. So this is why this line of line joining Q1 and Q2 is a line of unstable equilibrium. Because if I put the charge minus Q, it is not able to return back to its original case. Are you able to get me or not? मतलब सिंपल सी बात है भाई कि सर इसकी अट्रैक्टिव फोर्स ज्यादा है तो ये इधर ही पुल्ड होते हुए चला जाएगा ना, क्योंकि इधर की तो अट्रैक्टिव फोर्स कम होते जा रही है बार 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 बार, है कि नहीं। ओके। Okay, now let us repeat this same case. But this is only happening for the negative charge, isn't it? For positive charge, the case was totally different. In question, they will mention you the charge, and based upon that, you have to reply. Okay. So once again, over here, I have a negative charge. Okay. हाँ, ये नेगेटिव चार्ज है, तो अब ध्यान से देखो, इस बार जो फोर्स है, द फोर्स विच इज एक्टिंग ऑन Q1 and Q2 are totally different, isn't it? How it is different? So see that this Q1, this is going to feel attracted towards plus Q, isn't it? And this one will also feel attracted from both the sides. Which kind of force is there? Attractive force, isn't it? So let's suppose if I displace the particle a little bit upwards, okay, if I just displace the particle a little bit upwards here, if I displace the particle a little bit upwards or downwards, yeah, upwards or downwards, so then it used to go away, isn't it? But here, if I just displace it upwards, the charge will be once again attracted and it will come downward because the net force direction is in which direction? It's in the downward direction, isn't it? Even if you displace it downwards, due to the attractive force, it will come towards the center. The velocity will suddenly become less, and then once again it will jump back to its initial condition. Yeah, so here the line joining, sorry, the line perpendicular to line joining Q1 and Q2 is a line of stable equilibrium. So we have two different cases. First was two charges were positive. The third one placed was also positive. Then this line was stable. This line was unstable, isn't it? Here, if two charges are positive and one is negative, then this one becomes unstable and the vertical one becomes stable. Are you able to get me or not? Is this clear? ठीक है? Okay. So now, based upon this, I'll give you one question of this stability and instability. Okay. Question is, बोल रहा है कि on a line there are two charges, one is plus 4e, another one is प्लस ई। ठीक है, बोल रहा है कि एक प्लस 4e है और दूसरा क्या है, प्लस ई। हाँ, बोल रहा है कि the distance gap between them right now, between these two charges, is how much, a। then question is, where should a third where should a third charge must be placed, where should a third charge must be placed so that so that the system is in so that the so that the system is in equilibrium। okay, good, so that the system is in equilibrium। The question is, next case is, this is the first question. The most important question is, find the case in which in which the equilibrium will be stable and unstable। बताओ। okay, 2/3a। so whether it is stable or unstable, can you tell me? चलो भाई सॉल्व कर देते हैं, है ना। बोल रहा है कि वेयर शुड अ थर्ड चार्ज दैट मस्ट बी प्लेस्ड सो दैट द सिस्टम इज इन इक्विलिब्रियम, फाइंड द केस इन व्हिच द इक्विलिब्रियम विल बी स्टेबल एंड अनस्टेबल। अरे कुछ भी करो, चार्ज जहां पर भी हम प्लेस करें इक्विलिब्रियम में है तो उसके ऊपर एफ नेट की वैल्यू क्या है, जीरो, है ना। एफ नेट मस्ट बी इक्वल टू हाउ मच, जीरो। अब एफ नेट जीरो है तो इसके लिए क्या करना होगा, सिंपल, इसके ऊपर जो फोर्स लग रहा है, मान लो दिस इज लोकेटेड एट अ डिस्टेंस हाउ मच, एक्स। ठीक, तो ये डिस्टेंस क्या हो जाएगा, ए माइनस एक्स, या दिस इज एक्स, दिस इज ए माइनस x, isn't it? Okay, now, so this will be the force applied by plus 4e towards this side, and this will be the force applied by plus e towards this side. And these forces must be balanced. These forces must be also equal to each other, isn't it? So simple सी बात है, this is plus 4e on q, and then this force is plus e on q. So that must be equal. तो equal है होगा तो क्या होगा? Simple, sir, 1 by 4 pi epsilon naught q into plus 4e, और प्लस 4 से कितना डिस्टेंस पर है? x डिस्टेंस पर है, तो x स्क्वायर मस्ट बी इक्वल टू 1 by 4 pi epsilon naught q into e डिवाइड बाय a माइनस x का होल स्क्वायर, इजंट इट? यही आ रहा है इक्वेशन, ये कैंसिल, क्यू क्यू कैंसिल, इक्वेशन क्या आएगा? a माइनस एक्स बाई एक्स का होल स्क्वायर इज इक्वल टू 4। तो देखो a माइनस एक्स बाई एक्स की वैल्यू आई क्या चीज? प्लस माइनस टू। आई एम जस्ट कंसिडरिंग प्लस माइनस टू ओवर हियर। आर यू एबल टू गेट मी और नॉट? हाँ, प्लस माइनस टू मानना पड़ेगा ना, है कि नहीं? You have to always consider plus minus 2 always. Are you able to get me or not? So what I'm left with, a by x minus 1 is equal to plus minus 2. इसको सॉल्व करो, क्या आएगा देखो, ठीक है? तो इसके से x इज इक्वल टू, एक वैल्यू आएगा 2a by 3 और दूसरा वैल्यू आएगा x का x इज इक्वल टू 2a। तो देखो यहाँ पे हमारे पास x की दो वैल्यूज मिल गई ना, कि मतलब अगर हम प्लस 4e और प्लस e के बीच में रख रहे हैं, तो आई कैन प्लेस these particular charge over here also and somewhere over here also, twice a at some distance, okay? तो अब पॉइंट ये आता है कि इन दोनों में से, मींस इफ आई प्लेस इट एज x is equal to 2a by 3 और if I place it as x is equal to 2a, out of both of these, which one is a stable equilibrium and which one is a unstable equilibrium, that you have to decide, and that you have to tell. How you are going to decide is you are going to solve that by the method of analogy. You are not going to solve it numerically. You are able to get me or not? ठीक है? So look over here. अब ध्यान से देखो. Let us talk about that. So first point first, कि सर हमें मालूम है कि इस प्लस क्यू को हम अगर बाहर वाले पॉइंट पे रखते हैं, तो यहाँ पर ये पॉसिबल नहीं है इसको रखना, है कि नहीं? Because if x is equal to 2a, then that means what? It is somewhere over here. But between two positive charges, the charge must be placed in between it, isn't it? So first thing, x is equal to 2a is not possible. So only x is equal to 2a by 3 is possible. Are you able to get me or not? So look over here. Now, here, the second point was, now this was my first point. Second point was, the charge q which we have considered over here was a positive charge. किस तरह का charge है? तो एक बात बताओ, if I place it over here, which is positive, if I just place it over here, which is a positive charge, तो हम इसके previous case के discussion पे जा सकते हैं ना? अगर मान लो दो positive charge है, उनके बीच में अगर एक positive charge रख दिया, तो ये line कौन सा line है? Stable equilibrium का line है या unstable का? It's a line of, this is a line of stable equilibrium, isn't it? So इसका मतलब क्या मालूम चला कि x is equal to 2a by 3 is a point of stable equilibrium. Yeah. If q is positive. Are you able to get me or not? Is this clear? So, second point, if q is negative, if my q is negative, then we know that between two positive charges, if I place a negative charge, then this line becomes a line of unstable equilibrium, isn't it? So, हाँ, is a point of unstable equilibrium. ठीक है, तो कभी भी तुमसे कोई पूछे कि क्या हम दो पॉजिटिव चार्जेस के बीच में पॉजिटिव रख सकते हैं, नेगेटिव रख सकते हैं, हाँ ट्रू, आई कैन प्लेस एनी ऑफ द चार्जेस, पॉजिटिव और नेगेटिव, बट द पॉइंट इज इन वन केस इट इज अ स्टेबल, हाँ, yeah, so in one case it is a stable equilibrium, in another case it is a unstable equilibrium. Are you able to get me or not? So देखो जेई में, जेई मेंस और एडवांस में ये दो तरह के क्वेश्चन आते हैं, बार बार रिपीट हो गए आते हैं। वो ऑप्शन इस तरह से देते हैं q इज इक्वल टू 2a/3, सॉरी x इज इक्वल टू 2a/3, ठीक, q इज पॉजिटिव, और लिख देंगे स्टेबल इक्विलिब्रियम, दूसरा ऑप्शन बना देंगे, तीसरा ऑप्शन, ऐसे चार ऑप्शन बना देंगे और तुम कंफ्यूज होते रहो। तो कंफ्यूज होना नहीं है, पहले पॉइंट निकाल लो, पॉइंट निकालने के बाद बस उन दोनों के बीच में अपन उनका केस स्टडी कर लो कि अगर दो पॉजिटिव उनके बीच में एक नेगेटिव है तो लाइन अनस्टेबल हो जाती है, दो पॉजिटिव और एक बीच में एक पॉजिटिव है तो लाइन क्या हो जाती है, स्टेबल इक्विलिब्रियम हो जाती है। इज दैट क्लियर और नॉट? इज दिस टोटली क्लियर? कैन वी मूव टू नेक्स्ट क्वेश्चन? Okay, so let us just try one more question right now. All right. Now, I'll just bring this stability and instability of equilibrium with the help of oscillation. Okay. तो बोल रहा है कि मान लो सर, अगर दो चार्जेस हैं, ठीक, there are two charges, एक है तुम्हारा प्लस क्यू, दूसरा भी है प्लस क्यू, ठीक है, and the distance between them is twice d. The distance between them is exactly how much? Twice d. Okay. Now, along the line joining these two charges, I placed one very small pinpoint charge, a small cube, which has mass m also. Why or not? Question is, if I displace this charge by a small distance x, okay, if I displace this charge by a small distance x, and the question is, if x is too much less than distance d, then find the omega of q, and so that it is doing SHM, and so that it will do SHM. बताओ। सॉरी, मतलब अपन ने क्या किया, दो पॉजिटिव चार्जेस लिए, उसके बीच में एक और पॉजिटिव चार्ज गुजेड़ दिया, हाँ, और उसको हल्का सा डिस्प्लेस कर दिया बाय डिस्टेंस x। नाउ दिस डिस्प्लेसमेंट x इज वेरी वेरी लेस देन इवन d। तो बताना है कि ये चार्ज SHM करेगा या नहीं करेगा, अगर SHM किया तो इसकी एंगुलर फ्रीक्वेंसी क्या होगी। हाँ, we'll find the angular frequency if it does the SHM. So first you have to find whether it is going to do the SHM or not. अरे सैम भाई कहाँ चले गए? महेश, हेलो हेलो, बनाइए बनाइए इस क्वेश्चन को, पता करिए कि ये चार्ज SHM करेगा या नहीं करेगा? And if it is going to do the SHM, find the angular frequency. Okay, so first of all, you have to verify whether it is going to do the SHM or not. And one of the most easiest thing to understand whether it will do the SHM or not, you have to check whether the particle is in stable equilibrium or unstable equilibrium. Look over here. Stable equilibrium always says that the particle will always do the SHM. Okay. So if it is, these two charges are positive, and if I place this charge as also positive, then we know that the line joining two positive charges is always a stable equilibrium. Are you able to get me or not? क्योंकि इस चार्ज के ऊपर इधर का फोर्स दूंगा तो इधर से रिपल्सन बढ़ेगा, फिर ये धक्का मार के पीछे आएगा, फिर इनिशियल पॉइंट, फिर इधर जाएगा, फिर ये आएगा, तो डेफिनेटली ये पार्टिकल क्या करने वाला है, एसएसएम करने वाला है. बट तुम्हें पता करना है, हाँ, but you have to find the equation of SHM. First of all, you have to first find the equation of SHM. चलो इसका मैं जूम इन व्यू बताता हूँ, देखो कैसे होता है, समझो जरा. एनीवन गॉट द इक्वेशन ऑफ एसएचएम? यूट्यूब लाइव पे कोई भी, किसी को मिला? ये है प्लस क्यू, ये है अपन का प्लस क्यू, है ना? और इसके बीच में अपन का रखा हुआ है स्मॉल क्यू, जिसको हम x डिस्टेंस से मूव करा रहे हैं. ठीक, तो ध्यान से देखा जाए, अगर ये टोटल डिस्टेंस 2d था तो प्लस क्यू से ये डिस्टेंस हो जाएगा x प्लस डी, और इस प्लस क्यू से ये डिस्टेंस हो जाएगा x माइनस डी, सॉरी d माइनस x. एसएचएम इक्वेशन लिखने का मतलब है कि इफ दिस चार्ज हैज केम ओवर हियर, you have to write the net force equation on it. That's how we are going to find the angular frequency. What we need to do, we need to write the net force equation. So F net will be what? Simple सी बात है, this charge will repel, this charge will also repel. The repulsion with this plus q will be more. So I'll write F net is equal to 1 by, I'll take 1 by 4 pi epsilon naught common, and then charge is also same, so I can take q into q by 4 pi epsilon naught common. First distance it will come as 1 by d minus x का whole square minus 1 plus d plus x का whole square. This will be my resultant force equation, isn't it? Are you able to get me? यही होगा ना, d plus x d minus x square plus जो भी है. तो एफ नेट जैसे ही मालूम चला, ये मेरा एफ नेट है, अब इसको मैं सॉल्व कर सकता हूँ. सो एफ नेट विल बी q इंटू कैपिटल q बाई 4 पाई एप्सिलॉन नॉट. इसको सॉल्व करो तो क्या आएगा, इट विल बी, यहाँ तक किसी को डाउट नहीं ना? d प्लस एक्स होल स्क्वायर, इसको सॉल्व करो क्या आएगा, d प्लस एक्स होल स्क्वायर माइनस d माइनस एक्स होल स्क्वायर, है ना? ध्यान से देखा जाए तो एफ नेट बराबर q कैपिटल Q बाई 4 पाई एप्सिलॉन नॉट. ये है क्या टर्म, इसको हम एक्सपैंड कर सकते हैं, तो सारे वो डी स्क्वायर एक्स स्क्वायर वाले टर्म कैंसिल हो जाएंगे, बचेगा क्या? इट विल बी, आई विल बी लेफ्ट आउट विथ, मैं लिख देता हूँ डी स्क्वायर प्लस एक्स स्क्वायर माइनस ट्वाइस डी प्लस ट्वाइस डी एक्स माइनस ऑफ डी स्क्वायर माइनस एक्स स्क्वायर माइनस माइनस प्लस ऑफ ट्वाइस डी एक्स, इजंट इट, डिवाइडेड बाय, अच्छा ये दिख रहा है क्या, ये a प्लस बी ए माइनस बी का फॉर्म, तो हम इसको लिख सकते हैं डी स्क्वायर माइनस एक्स स्क्वायर का होल स्क्वायर. आर एबल टू गेट मी और नॉट? इज दैट क्लियर? सो दिस एंड दिस गॉट कैंसल्ड. आई एम लेफ्ट आउट विथ एफ नेट इज इक्वल टू कैपिटल Q स्मॉल q by 4 pi epsilon naught twice dx divided by d square minus x square का होल स्क्वायर. अब ध्यान से देखा जाए तो क्वेश्चन में पहले ही स्पेसिफाई किया गया कि सर ये जो x डिस्प्लेस, it will be 4 dx. Okay, you just replace it by 4 dx. Okay, question itself says that the x is a very small value. X is too much less than d. So that means what? This d square minus x can be written as just d square. So fnet becomes capital Q, small q, 4 dx. How come you can ignore x in numerator? You can't. So 4 pi epsilon naught d to the power of 4. This is your equation of fnet over here for the small oscillation. Are you able to get me or not? Is this clear? So this is net force equation. Remember this equation, learn कर लो ऐसे है ना. Net force equation for a small oscillation. ठीक है. चलो, तो हमें नेट फोर्स इक्वेशन मिल गया. हमें मालूम है एसएचएम में हमें क्या निकालना रहता है, नेट फोर्स इक्वेशन ही निकालना रहता है. जो पार्टिकल एसएचएम करे उसका नेट फोर्स निकाल दो, तो वो तुरंत मालूम चल जाएगा कि उसकी एंगुलर फ्रीक्वेंसी क्या है. कैसे? तो सर हमें मालूम है कि नेट फोर्स को हम लिख सकते हैं, आई कैन राइट इवन नेट फोर्स एज if the force is present then it has mass into acceleration, isn't it? So mass into acceleration is equal to capital Q small q 4dx. अच्छा डी डी कैंसिल हो जाएगा यहाँ पे, तो बचेगा x 4x बाई क्या बचेगा 4 पाई एप्सिलॉन नॉट डी क्यू, isn't it? तो एक्सेलरेशन का तुम्हारे पास इक्वेशन आ गया a इज इक्वल टू, इक्वेशन आया a इज इक्वल टू माइनस, इसमें माइनस आएगा क्या और प्लस ही रहेगा, माइनस कहीं नहीं आ रहा है ना. ठीक है, तो आई कैन राइट 4 कैपिटल क्यू स्मॉल क्यू. हाँ, डिवाइड, आई कैन इवन कैंसिल 4. सो लेट अस कैंसिल 4, तो बचेगा कैपिटल क्यू स्मॉल क्यू बाई पाई एप्सिलॉन नॉट डी क्यू m पाई एप्सिलॉन नॉट डी क्यू. ओके, इनटू x. और यही तो फॉर्मूला होता है ना एसएचएम. अगर पार्टिकल एसएचएम कर रहा है, एफनेट का इक्वेशन आ गया, तो वी नो दैट आई कैन राइट, इफ आई कैन राइट a इज इक्वल टू माइनस ऑफ ओमेगा स्क्वायर x फॉर्म. अगर हम उस एफनेट में से ये फॉर्म लेकर आ जाते हैं तो एंगुलर फ्रीक्वेंसी मालूम चल जाती है ना. तो हरदम याद रखना, कहीं भी कोई पार्टिकल एसएचएम करे तो सबसे पहला स्टेप है उसका निकालो एफनेट. क्योंकि एफ नेट को हम लिख सकते हैं इट इज इक्वल टू एम ए, और जैसे ही हमने एम ए लिखा, अगर हमारा एम ए में इक्वेशन इस तरह से हम स्टैब्लिश कर दें माइनस ऑफ ओमेगा स्क्वायर एक्स, सो दिस मीन्स ओमेगा स्क्वायर इज इक्वल टू कैपिटल क्यू स्मॉल क्यू by m pi epsilon naught dq, and that's what is your angular frequency. Omega is equal to, yeah, this is your omega of small oscillation over here. ठीक है, इसको 4 पाई एप्सिलॉन नॉट में भी लिखा जाता है. इट इज ऑल्सो, आई कैन राइट इट इन टर्म्स ऑफ k. It will be 4k capital Q small q divided by m dq. That is, this is your one of the answers which are also correct. Is this clear? Totally. ठीक है, so we got to know what happens if the oscillation is on the horizontal path, isn't it? The question remains still intriguing. What happens if the oscillation is on the vertical path? So once again, let's suppose if I have some charges plus q plus q, okay, and then I placed, uh, let me just place this charge over here on the vertical line, okay. I have placed this charge, a small q over here, right or not? द पॉइंट इज वेरी वेरी क्लियर कि यहाँ से लेके यहाँ तक का जो डिस्टेंस है वो है 2D। ठीक, ओके। Then question is simple. If I displace this particle by a very small displacement x, okay, and this charge is, let me just see, I think this charge will be negative charge. Then only it will do SHM, okay. So I do the displacement x very small, and this charge is minus q. Okay, then question is, if x is less than d, then find equation of SHM and angular frequency and omega of SHM. If this is a perpendicular bisector 0, 0, ठीक है, बताओ। So we have completed some good amount of questions till now, isn't it? Good. Do it. Try to do it fast. इसके बाद में वो डाइलेक्ट्रिक कांस्टेंट वाला जो आता है ना, पानी के अंदर डुबो दिया, ये कर दिया, वो कर दिया, उस तरह क्वेश्चंस करूंगा, है ना। पानी के अंदर वाले क्वेश्चंस, ओके। पूरा हो पाएगा। A small displacement है, you have to think like that way, that I'm doing a small displacement. You can if it is not easy, then you can do one thing. You can take this analogy. Consider this x distance from here to here. Okay, the charge is getting displaced very small, so I can consider from here to here. Right or not? Okay. So now your question will become very easy. देखो देखो एक बात समझो. Plus q will try to attract this charge along its own line, isn't it? है कि नहीं? Similarly, this plus q will also attract the charge along its own line. Let's say this is F1 and this is F2. Now, if this is a perpendicular bisector, then this distance is d and this distance is also d, isn't it? So this distance is exactly root under d square plus x square. This distance will be also same, root under d square plus x square. So what do we got to know? That these two forces F1 and F2 are exactly same, isn't it? And if these forces are same, what will be its relation? K into Q into small q. I have already taken the direction, so no need to consider the negative sign. Okay, divided by root under, sorry, d square plus x square का whole square. So we got the F1 and F2 equation, that F1 is exactly equal to F2, which is equal to K capital Q small q divided by d square plus x square. Now look over here. If you just resolve these two forces, okay, then let's suppose I call this as angle theta. So this angle will be also angle theta. So this will be also theta, isn't it? So this will be one component of force F1 and another component towards this side. This will be one more component, and this will be also another component, isn't it? So what do you observe? That the cos theta component of F1 and F2 both are getting cancelled while the sin theta component is getting added or not, isn't it? So this means that F net becomes how much? F net is F1 sin theta plus F2 sin theta, which are exactly same. So F net I can write it directly as twice of F, which is exactly equal to F over here, twice of F sin theta. Are you able to get me or not? Is this clear? Bro, there is no one who might be watching, but it's just live. Okay, so can we move ahead? इतना तो clear है? So now F net is how much? F net is exactly equal to twice k capital Q small q divided by d square plus x square. और sin theta क्या है? Sin theta is perpendicular x by base by hypotenuse. So x, so it becomes twice k capital Q small q x divided by d square plus x square to the power of 3 by 2. Once again, x is too much less than d. So this term can be ignored easily, isn't it? So if I ignore it, I got my f net, and f net is twice k q q x divided by d to the power of d to the power of 3. Are you able to get me or not? Now I can write ma is equal to f net. So ma is equal to twice k capital Q small q x divided by d cube. So a is equal to twice k capital Q small q divided by m d cube into x. I'm ignoring the minus sign. So this becomes omega square, isn't it? But this is omega square for the vertical oscillation. Angular frequency for vertical SHM, isn't it? And this provides us the answer. What can be the angular frequency in vertical case? So omega will be root under twice k capital Q small q divided by m d cube. You see that there is a point over here that omega in horizontal case is exactly equal to root under 4k capital Q small q by md cube, and omega in vertical case is twice k cube by md cube. So what we got to know that if my charges are placed in such a fashion, then in vertical case the angular frequency is less, while in horizontal case the angular frequency is more. Are you able to get me or not? Is this clear? Are you able to totally get it? Any kind of doubt till now? No, confirm. Okay, so should I give one more question? So this was about your stability, instability, and the point related to angular frequency of small oscillations. Got it or not? We can still, there can be many kind of different questions which you can ponder, which you can see online, and you can practice them easily. Is that clear or not? Okay, so means the point is very simple. You can find it out in the vertical case. You can find it out the like Horizontal case, you can have different analogies. Okay. Heard or not? Okay, let me check one more question. I think okay, so I think I'll pause it over here. Okay, heard or not? So I think still 10 minutes are left, but